What a splendid day to each one of you. I'm Ashiko de la Cruz and I'm here with my fellow group members, Elmi Alimsub, Kent Balasi, Abra Bungaling, Bernice Nicole Francisco, Charlie Suzanne Palero, Axel Penaflor, and Alaina Velosa. Today we will be introducing and talking about anti-differentiation, particularly about its history, application in the Mindanao context, fellow world problems with solutions, and tips that encourage you to be more motivated and enlightened in learning thoroughly the concept of anti-differentiation.
History of anti-differentiation. In 1675, on October 29th, Gottfried Leibniz wrote the integral sign in an unpublished manuscript, thus the beginning of anti-differentiation. Gottfried Leibniz was a German mathematician and philosopher who excelled in bridging academic fields. He possessed a legal degree, was secretary of the Nuremberg Alchemical Organization, and considered himself a poet. In addition, he served on diplomatic missions in London and Paris. During his visits to various places, Leibniz met scientists such as Christian Huygens, Robert Boyle, Robert Hooke, John Pell, and Jacques Ozanam. He was elected a Fellow of the Royal Society after displaying an incomplete calculation machine to them. Leibniz addressed his interest in summation series and infinitesimal geometry with his English colleagues, and he communicated with them after he returned to France. They briefed him about the literature on the topic as well as Isaac Newton's unpublished work on the subject. Newton responded to Leibniz via an intermediary, and they began a series of letters that frequently took weeks or even months to reach their destination. The confused back and forth eventually led to a feud, with Newton charging that Leibniz had stolen his work in establishing the science of calculus. Newton's letter, on the other hand, described outcomes rather than techniques. Leibniz's training in legal and philosophical formalism enabled him to develop his own symbolic system, which included not only the integral sign, but also the same notation of differentials that we still use today. Newton's system was published somewhat before Leibniz, but the German notation was superior. Continental and English mathematicians would argue for decades about who created calculus, but it appears to be another case of simultaneous discovery. The two scientists were from the same period, moved in the same circles, studied the same forefathers' work, and shared some of their own views. It should come as no surprise that they arrive at the same conclusions in a somewhat different mathematical language at almost the same time.
Leibniz made significant contributions to our understanding of differential equations. He devised the method of variable separation, first reducing homogeneous equations to separable equations, and then figuring out how to solve first-order linear equations. He was also involved in the multinomial theorem. He was very aware that choosing a decent notation was critical, and he gave it considerable attention. Newton, on the other hand, wrote more for himself, and, as a result, preferred to use whatever notation he felt like using at the time. The operator aspect was emphasized in subsequent versions by Leibniz's notation of d and integral sign. Leibniz had agreed on the notation by 1675 in the form of integral y dy equals to 1/2 y squared. This is exactly how it would be phrased now. His work on integral calculus was published under the term Calculus Summatorius in 1684 to 1686. Jacob Bernoulli introduced the name integral calculus in 1690. Jacob Bernoulli and Johann Bernoulli continued the development of calculus after Newton and Leibniz. However, when Berkeley wrote his Analyst in 1734, he attacked the lack of rigor in the calculus and contested the logic on which it was founded, and great effort was made to strengthen the reasoning. Maclaurin sought to establish the calculus on a strict geometrical foundation, but the truly adequate basis for the calculus had to wait until Cauchy's work in the 19th century.
Hello. Anti-differentiation has many applications that can be observed all through the systematic approaches on the island of Mindanao. There are various prospects that can be highlighted by using the concept of anti-differentiation. This can be analyzed thoroughly by business companies, therein stimulating what future expenditures or capital they can obtain from their daily negotiations. This can be applied in science wherein a physicist is determined to collect data about a particular particle's velocity, or a biologist is processing the maximum population of various species. Thank you.
Not only that, this can be pinpointed in other courses such as engineering and meteorology. In engineering, this can be overviewed upon the amount of space that can be established and the weights of the foundation in order for other materials to withstand such style. On the other hand, a meteorologist can be also perceived wherein gathering data and forecast systems on what typhoons can be anticipated and their heavy impacts on different regions when occurred. All in all, these instances delineated a proper layout of how anti-differentiation plays a vital role in every major courses society is provided and reflected upon. It is indispensable as it is congruently to how each aspect in life can be calculated and observed several times when applying the various methods and theorems anti-differentiation has rendered in Mindanao.
Solve problems. For algebra, problem number 1. Miss Yelan, a renowned architect, has a multi-million project in Mindanao, particularly a dome-shaped bridge from Igacos to Davao City. With her team, they planned the blueprint and listed down all materials needed. As a journalist, we interviewed her and asked what were the ways she did in order to perfectly execute this project. She said she was using integrals or anti-differentiations of values. Particularly, she used the second theorem, the product rule. The value was the integral of 8x squared of dx. To show her solution, we will illustrate it using these steps. First, among the theorems, product 2 or the product rule is the most applicable in solving this problem. For a real number n, the indefinite integral of f of x is equal to x over n, which is the integral of x over n times dx is equal to x to the exponent of n plus 1 over n plus 1 plus c, wherein c is the constant of integration. In the next step, we must evaluate the integral of 8x squared times dx. Here, the integral of 8x squared times dx is equal to 8 to the integral of x squared, which is applying the property of 1. When we apply the product rule, we get 8 to the integral x squared of dx is equal to 8 multiplied by x squared plus 1 over 2 plus 1 plus c, wherein simplified as 8x cubed over 3 plus c. 8x cubed over 3 plus c. Explanation. As what the solution stated, we can let n be any random number, as long as n is not equal to -1. This indicates that our formula is applicable not just to whole numbers, but also to negative, rational, and irrational numbers, as long as n is not equal to 1. For our conclusion, therefore, by using the formula 8x cubed over 3 plus c, the project was executed perfectly, and Miss Yelan built a wonderful dome-shaped bridge.
Problem number 2, using trigonometric. John Smitten, an engineering project manager, is responsible for the design and construction of bridges and canals in Mindanao, precisely a proposed bridge that likewise connects Davao City and Sama. Being the project manager, he asked his fellow associate engineering technologists as well as the DPWH to provide the stuff and information required. Me, as a student who aspires and would likely to pursue the same profession in the future, was astonished and cared to ask on how he would conduct the proposed project. What would be the equation that will be utilized for engineers and workers to help initiate the construction of Davao-Sama Bridge? For our solution, we'll be using the formula of the integral of cosine x with respect to x equals to sine x plus the constant integration. First, let's evaluate the integral. Integral 4x cosine x to the power of 2 dx. Then, choose the substitution part. U equals to x to the power of 2. And differentiate both sides. Du equals to 2x dx. Then, we need to isolate the dx. Thus, it will become... Next, we need to isolate the dx. Thus, it will become dx equals to 1 over 2x du. And substitute back into integral of 4x cos u multiplied to 1 over 2x du. Then reduce the expression to the lowest term. Integral of 2 cos u. Then reduce the expression to the lowest term. Integral of 2 cosine u du. Next, we need to apply the property of integral, which is integral of kf of x with respect to x equals to k integral of f of x dx. And it will become 2 integral of cosine u du equals to 2 integral of cosine u du, which is u is equals to x squared. Next is we have to evaluate the integral using integral of cosine x with respect to x equals to sine x to become 2 sin u, where u is equals to x squared, it will become 2 sin u. Substitute it back to 2 sine x squared. Then add the constant of integration, often denoted as c, so the answer will be 2x squared plus c. In conclusion, as a result, the formula was the one that led the proposal to perfection. The project proposal of the Davao-Sama Bridge was constructed impressively in consideration of the engineering project manager accompanied by DPWH and his associates.
Problem 3. The local government of Davao wants to construct an indoor stadium that would host 90,000 concert-goers in the near future. Through the immense amount of space, the government decided to navigate and extract all the possible resources that can be found. In order to maximize also the given space, environment, and budget, the government has decided to use an equation that can easily establish and how large the indoor stadium is once built. The equation will be the integral of 4x cubed multiplied by x to the exponent of 4 minus 5 cubed of dx, where x is equals to 2 and c is equals to 17. With that, how large will be the indoor stadium be? The measurement must be in meters and round off to the nearest whole number. To begin solving, the given equation was that the integral of 4x cubed multiplied by x to the exponent of 4 minus 5 cubed of dx. Proceeding to the next step, we must identify what is the value of u and its derivative, which is du. Through that, the value of u is equal to x to the exponent of 4 minus 5, while the value of du is equals to 4x cubed of dx. In transcribing the new equation, the integral of 4x cubed multiplied by x to the exponent of 4 minus 5 cubed of dx will be now the integral of x to the exponent minus 5 cubed 4x cubed of dx. So, the integral of x to the exponent minus 5 cubed 4x cubed of dx, right? In knowing the formula, we must apply the formula for theorem 1 or the general power rule. But first, the equation now will be enlisted as the integral of u cube of du. Upon next, the value of u to the exponent of 3 plus 1 over 3 plus 1 plus c. In simplifying the equation, it will be now u to the exponent of 4 over 4 plus c. After that, we must substitute the value of u, which is x to the exponent of 4 minus 5, hence raised to 4 over 4 plus c. Here, this is the equation that we will be utilizing. However, it is not yet the final answer. We must substitute also the values of x and c. As we prolong further, the equation is now x to the exponent of 4 minus 5, hence raised to x over 4 plus c, while the value of x is 2, while c is 17, right? Here, we must substitute the given values into the equation. In substituting them in the equation of x to the exponent of 4 minus 5 to the raise of 4 over 4 plus c, it will transfer as 2 to the exponent of 4 minus 5 to the raise of 4 over 4 plus 17. When simplifying the values, the equation will now be 11 raised to the power of 4 over 4 plus 17. The value of 11 raised to the power of 4 will now be 14,641 over 4 plus 17. Here, the tentative value is now 3,660.25 plus 17. When adding both values, it will now be 3,677.25. However, we must round off it as a whole number, so the overall answer is 3,677 plus the measurement, which is meters. So our final answer will be 3,677.25 meters. In order to draw the conclusions, the conclusion will now be that the size of the indoor stadium once built by the local government of Davao City will be about 3,677 meters.
Davao City has been suffering from long and time-consuming traffic due to the type of road intersection that's been used. GPWH needs to create a new type of road intersection to greatly reduce the traffic that Davao City is experiencing. An engineer in Davao City is tasked to develop a new and improved road intersection, but he is stumbled upon an equation that keeps him from determining what the right and suitable road intersection type will be used. The equation is 2 sine times x squared plus c. Here, we need to solve the equation so that the problem of the traffic will be solved. In finding the antiderivative of this equation, we must use the u substitution method. Let us elaborate on the following steps ahead. First, we must identify the variables. The value of u is equal to 5x while its derivative is 5 dx. On the contrary, there is no 5 that can be seen in the equation. Rather, we must solve for the value of dx in replacement for du. We must solve the value of du as 5 of dx can be divided by 5 on both sides. So, the final expression will be now as dx is equal to du over 5. Moving on, the equation of the integral of cosine 5x of dx would now be as integral of cosine of u over 5. As you can see, that there is a constant value which is 1 and 5. We can factor them out and simplify. Now, the equation would be now 1 over 5 to the integral of cosine of u of du. After that, we must apply the concept of pure and two or trigonometric functions, as there is a cosine that can be perceived in the equation. In that, we must apply 2b, where the integral of cosine of u of du is inversely into the sine of u plus c. We can process the equation would now be 1 over 5 sine of u plus c. In looking back at the value of u, we must substitute it in the equation. Consecutively, the final answer is 1 over 5 sine of 5x plus c. Therefore, the equation that should be utilized is 1 over 5 sine times 5x plus c in order for the engineer to solve the rampant traffic problem.
Problem number 5. Assume that an Ateneo de Davao University student is experimenting. He wants to find and solve first the equation of the integral of 14e to the power of 21x of dx to observe the rate of bacteria growth in a Petri dish. With the use of the formula of the antiderivatives of exponential functions in Theorem 3a, in which the integral of e to the exponent of u of du is equal to e over u plus c. Solve the equation. First, we must determine what is the value of u and its corresponding derivative, which is du. Here, the value of u is 21x, as you can see, the concept of exponential function. Meanwhile, the value of du is 21. However, based on the function given, there is no value of 21 of dx that can be seen in the equation. We must identify the value of dx, which is dx is equal to du over 21. After finding the value of u and its derivative, we can now presume. The new function pertained would now be as the integral of 14e to the power of u times du divided by 21. Moving on, we must simplify. As you can see that the values of 14 and 21 can be simplified. So, let's group them together. The equation would now be as the integral of 14 over 21 of e to the exponent of u of du. Further simplification, 14 over 21 is considered a constant value. We can factor them out and can be simplified as 2 over 3 outside of the integral. Now, the equation is now hereby as 2 over 3 to the integral of e raised to the power of u of du. In integration, the equation would be converted as 2 over 3e to the exponent of u plus c. Onto drawing the final answer, the equation would now be 2 over 3 of e to the power of 21x, wherein we substituted the value of u plus c. Therefore, the equation that can help scrutinize the growth of bacteria in a Petri dish would be 2 over 3 of e raised to the power of 21x plus c.
Now, let us all discuss the following tips for future basic calculus learners. For future learners who aspire to seek STEM courses such as architecture and engineering, there may be tips that we want to emphasize for you to learn and effectively assimilate the given information about anti-differentiation. First and foremost, break down the concept that were tackled all throughout the sessions into various segments and pinpoints. This point is very important as not only it is convenient, rather it is also effective in comprehending the methods and procedures that were oriented in the lesson. It lets you gather and easily navigate what procedures you don't easily acknowledge and process evenly. Second, watch YouTube videos and or other media sources to help you further understand the complex methods and theorems discussed. And moreover, you must have complete or important notes when you start studying. It is essential that having notes is part of understanding the numerous methods encapsulated as it lets you cohesively comprehend the following steps and formulas that were enlisted during this session. With this, transcribing your notes enables you to become more familiarized and organized as you start to overview what particular methods and solutions that were applied in each problem oriented.
This aspect is very important as it lets you understand the difficult concepts that can be introduced to you as a student. Sometimes, watching videos also aids you in learning further as there are tendencies that you are an audio and visual learner that can easily gather and understand the information given to you more easily rather than reading off from a PDF or soft copy. Apart from that, practicing yourself through various practice tests helps assimilate and strengthen your knowledge on the topics encompassed. Pre-tests in particular help overcome your struggle as you familiarize and understand the different contexts, but same applied methods and solutions in answering the scenario given. Furthermore, implementing a plan or schedule helps yourself to become more disciplined as you comply, incentivize, and organize your tasks in different time blocks. Knowing what time you are designated to do a specific task reduces the probability of cramming your assignments and household chores all at once. And lastly, ask questions to further broaden your understanding based on the concepts tackled. Inquiring actually contributes to your knowledge and power as it aims you to connect the dots where there are certain formulas or methods you're not familiar with. Hence, it enables you to encourage yourself to find alternative routes in answering the problem but still achieve on having a correct answer.
As for our references, we have collected some of our content from other sources. We have collected information from the internet, scanned books, articles, and blogs. The information we have gathered is all valid and reliable, making the content of our video believable and reliable.
We'd want to thank you for taking the time to listen to our report on anti-differentiation, particularly antiderivatives, as we wrap up our presentation. We did our best to present the various aspects of the topic of antiderivatives. We've covered its history, real-world applications, and problem sets that demonstrate how antiderivatives are used in practice. We appreciate you taking the time to hear what we have to say. We hope you also learn something new and will reflect on it. We also hope that we clearly stated the problems and solutions, and we will look forward to working with you in the near future. That is all. Thank you.